Okay, hello everybody, what's going on? This is Muhammad, welcome to another video. In this video, I'm going to show you how to solve for this definite integral. So we have here the integral from 0 to 1, x to the power gamma, where gamma is the Euler-Mascheroni constant, minus e to power phi, where phi is the golden ratio, which is 1 plus the square root of 5 divided by 2, all divided by the natural logarithm of x dx. Okay, so how can we solve for this integral? If you guys are interested, pause this video, give this problem a try, and keep watching this video for a solution. So to solve for this integral, what I'm gonna do here, I'm gonna be splitting. First of all, I will add and subtract. I will subtract and add 1. Okay, so this is gonna be equal to the integral from 0 to 1, and x to the power gamma minus 1 between two parentheses minus, I will take the minus as a common factor, x to the power phi minus 1. So I have subtracted 1 and added 1 and left x to the power gamma and x to the power phi as they are, and everything has to be divided by the natural logarithm of x dx. And then I will split this into two integrals. So the first integral is going to be from 0 to 1 of x to the power gamma minus 1 over the natural logarithm of x dx minus the natural logarithm of the integral from 0 to 1 x to the power phi, which is the golden ratio, minus 1 divided by the natural logarithm of x dx. So if we can find, basically they look the same, except okay for different constant. This is gamma here and that's phi there. Okay, so what I'm gonna do, I'm gonna define a general integral, and I'll call that I of alpha, which is gonna be the integral from 0 to 1 x to the power alpha minus 1 divided by the natural logarithm of x dx. And what I'm going to do now, I'm going to differentiate both sides with respect to alpha. So alpha is going to be the variable here. So I prime of alpha is going to be equal to the integral from 0 to 1. And then the derivative becomes partial derivative. So partial by partial alpha of the x to the power alpha minus 1 divided by the natural logarithm of x. Let me close the brackets, dx. Now, the derivative here, the partial derivative here is with respect to alpha. So alpha is the variable, x is a constant. So this looks like e to power x, which gives us, okay, the same, right? The derivative of e to power x is gonna give us e to power x. Now, why? Because x is the variable and e, and then we have to multiply by ln e, but it's 1 in the case of e. Here, it's x to the power alpha, so it's going to be the same, x to the power alpha, except that we have to multiply by the natural logarithm of the base, basically, which is x. Okay? So this is going to be equal to the integral from 0 to 1, and this is going to give us x to the power alpha, the natural logarithm of x, minus 1, okay, the derivative of that is going to give us 0 because it's a constant, divided by the natural logarithm of x dx. And of course, ln x is going to get cancelled with the ln x, okay, and we're going to be left out with the integral from 0 to 1 x to the power alpha dx. How can we integrate this? Now, x is the variable because it's with respect to x, so this is going to give us what? X to the power alpha plus 1 divided by alpha plus 1 from 0 to 1. And that is going to give us, now we need to substitute instead of x. So that's going to give us 1 divided by alpha plus 1. So that is basically what I prime of alpha. Now what I'm going to do, I will integrate both sides. Okay, so that means that I of alpha is going to be equal to the natural logarithm of alpha plus 1, and we need to add up a constant c, which is the constant of the integration. Now the problem is to find the value for c. And for that, we need to substitute a particular value for alpha, and from that we can calculate C, okay? Solve for C. So for alpha equals to 0, that is gonna give us the natural logarithm of 0 plus 1, which is basically 0 plus C, and we need to evaluate I of 0 from the original integral, but we need to substitute instead of alpha here 0, so that's going to give us x to the power 0, which is 1 1 minus 1 0, so this whole integral is going to give us 0, so that makes C equal to 0. And from that we can conclude that I of alpha is the natural logarithm of the absolute value of alpha plus 1. Okay, now what is our original integral? It's nothing but I of gamma minus I of phi, which is the golden ratio, and gamma is the Euler-Mascheroni constant. Okay, so that is going to give us the natural logarithm of gamma plus 1 minus the natural logarithm of phi plus 1. And this can be simplified or rewritten in a compact form as the natural logarithm of the absolute value of gamma plus 1 divided by phi plus 1. And if we substitute the values for gamma and phi, this is going to be approximately equal to minus 0.507 minus 0.056 minus 0.506 763. That's the approximate value, of course, but of course we need to substitute the exact values for for phi and for gamma, and that is going to give us this final value. That is the final answer of this problem. If you guys like this video, hit like and don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching and see you in another video. Thanks.